Alright, so we are ready to start looking at linear inequalities in two variables. Then when we have two variables, we can't just use a number line to graph them, we have to graph on the coordinate plane. So what we have to do really is, when we have an inequality, two variables, have a less than sign here, what we have to do is graph the boundary line first. And the boundary line is the same as the inequality except for the inequality symbol is an equal sign. So what I'm going to do first is graph the boundary line. So the boundary line would be x minus y equals 5. So we replace the inequality sign with an equal sign. So if I want to graph this, I could use a t-chart to find a couple points, right? Maybe I'll use 0 for x. So if x is 0, we'd have negative y equals 5. So y would have to be negative 5, right? And we have 0 for y. Then we'd have x equals 5, and x would be 5. So that gives us a couple points. I used the intercepts. That was fairly easy to do in this case. So I'm going to plot those 2 points. 0, negative 5 is down here. And 5, 0 is over here. Now, if we have strictly less than, there's not an equal to, then this boundary line is going to be a dashed line, or dotted line if you want to call it that. So I'm going to use a straight edge to make sure it's nice and pretty. And I'm going to make a dashed line in this case, because we can't actually be equal to that line, right? Unless there were an equal to bar. But there's not an equal to bar, it's strictly less than. So I've graphed my boundary line. Now a boundary line will divide the coordinate plane into two pieces. Everything in this case on this side of the boundary line, and everything on this side of the boundary line. So what we're going to do next is pick a test point. We're going to test any point in the coordinate plane on either side of that line to see if it fits the inequality. And if it fits the inequality, we're going to shade toward that test point. So if the point 0, 0 does not fall on our line, then it's an easy one to check. So in this case, 0, 0 is right here. It's not on the boundary line. I'm going to test the point 0, 0. Okay? So I test 0, 0. I plug it into the original inequality. I get 0 minus 0 is less than 5. So 0 is less than 5. Is that true? It is true, right? 0 is less than 5. And so since that works, I'm going to shade everything on this side towards 0, 0, okay, of my boundary line. I like to use a highlighter because it's a lot easier to shade things. I'm doing these by hand. But we really just need to know which direction from this line to shade it. If I had a bigger highlighter, it'd be even better. But the good thing is, by hand, this takes a little bit of time to do. But you'll be doing all these in my lab. And in my lab, they have a nice little fill button. It's like a little paint can, and you can fill this side of the boundary line in one little click. And you don't have to do all the scribbles like I did. So when you're doing this on my lab, it'll be even easier than, or at least technically, it'll be faster than what it would be by hand. Of course, there's also the line graphing tool, which you've already had practice with. And there's an option to do a dashed line, so make sure if this is less than or greater than with no equal to bar that you have a dashed line and not a solid line. So basically what this says is any point on this side of that boundary line will work in this inequality. And if you're not sure, pick another point on this side, maybe the point negative 2, 1. Right? If I put in negative 2, 1, I'd have negative 2 minus 1 would be negative 3. That's still less than 5, right? Any point over here would work in this inequality. Let's look at another one. And I'm going to kind of go through the same process. So we start by writing that as equal to get our boundary line. I'm going to graph the boundary line. I'm going to use a t-chart again. And if I can use the intercepts, I'm going to try that. So let's put 0 in for x. That would give me, 3 times 2 is 6, so y would be 2. If I put 0 in for y, 2 times 3 would be 6, so I put 3 here. So I have my 2 points. I'm going to plot those. The point 0, 2 is here. The point 3, 0 is here. In this case, since there is an equal to bar, then the boundary line itself is part of the solution set, and we make it a solid line. So if there's an equal to bar, make sure you do a solid line connecting your points. So I have a solid line, and now we have to figure out which side to shade on. So if, again, 0, 0 is not on your boundary line, you can test it. 0, 0 is not on the boundary line, so I'm going to test 0, 0. If I plug 0, 0 in, I would have 0 plus 0 is greater than 6, so I'd have 0 is greater than or equal to 6, right? That's not true, is it? That's false. So if it's false, we don't shade towards 0, 0, we're going to shade away from 0, 0, which is going to go up this way from the boundary line. So I'm going to shade this area up here. Everything, I guess you could say, above the boundary line, right? So any point out up in this region, this half of the coordinate plane, would be a solution to that inequality. You could try another point. Maybe we do the point 4, 1. It's in that region. 4 times 2 is 8, plus 3, that's 8 and 3 is, well, 11. That is bigger than 6, isn't it? So it does fit the inequality. Again, on MyLab, you have a nice little fill tool that you can fill this whole region in with one little click. All right, let's look at the next one. We have x is less than or equal to, let's get this so we can see it better. All right, maybe we can do this. Just touch out of the way. All right, x is less than or equal to 4y. All right, so boundary line would be x equals 4y, right? So we can make a t-chart, I guess. This is not in the form that we had up here. It's not in standard form, but we can still plug in numbers. In this case, it's probably easier to plug in numbers for y and figure out what x is, right? If I plug in 0 for y, 4 times 0 is 0, we get 0 for x. If I plug in 1 for y, 4 times 1 is 4, we get 4 for x. And maybe I'll do one other point just to, maybe a negative. I don't know. We don't have to. Let's just do 2 points. Why not? 0, 0 and 4, 1. All right. Will this line be solid or dashed? Hopefully you said solid because we have the equal to bar, right? So I'm going to make a nice solid line here connecting those two. Alright, now we've been testing 0, 0, but notice 0, 0 is on this line, so we can't use it as a test point. We have to pick a point either up here or down here, right? Somewhere below the line or somewhere above the line. So let's pick a different test point. How about, well, I still like to pick an easy one, maybe one that's on an axis. Maybe the point 0, 2, which would be right here, right? That's above the line. So let's test 0, 2. If 0 is one of the coordinates, it's going to be easier to test because it's easy to plug in 0. So I'm going to pick 0, 2. I'll pick that guy right there. And if I pick 0, 2, if I put 0 in for x and 2 in for y, I would have, well, in the inequality, right, I have 0 is less than or equal to 4 times 2, which is 8, right? Is 0 less than 8? It is. So everything up here is going to work. And so we shade toward the test point. So everything above this line in this case is going to work. And I'm getting a little better at shading. We just need to identify that we are going this direction. Alright, so just to double check, you could also pick a point below here and make sure it doesn't work. For instance, I could pick the point 2, 0, which is below that line, right? If I pick 2, 0, I'd have 2 is less than 0. Doesn't work, does it? Good, because we didn't shade that side. Okay. All right. So if again, your inequality is true, then you shade toward that test point. That was true, and this one up here was true too, wasn't it? If your inequality ends up being false, you shade away from the test point. All right, here's another one. X is greater than or equal to -3, so your boundary line is x equals -3. You might say, well, this only has one variable, and you would be right, but you can still graph it in the coordinate plane. If you remember what type of line this is, and if you're not sure, you could still make a t-chart. All we know is x is -3, right? Y could be anything we want it to be. Y could be 0, y could be 5, y could be something else. But we only need 2 points, so -3, 0, -3, 5. And you could pick any value for y. I just chose a couple at random. But hopefully you recognize this from the past. This is a vertical line, right? And we have greater than. There's no equal to bar. So what kind of line we have? Solid or dashed. Okay, I hope you all said dashed, and then we'll connect this. And we get a nice dashy vertical line. All right, x equals -3. Now we have to decide which side to shade on. Well, it doesn't go through 0, 0, so I'm going to test 0, 0. Most of the time you can test 0, 0, but occasionally, like in the last in number 3 there, you'll have a line that goes through 0, 0, and you have to pick a different test point. But here, it doesn't go through 0, 0, 0. So let's test 0, 0. Plug it into this inequality. Is 0 greater than -3? Ah, it is, right? That is true. So we're going to shade towards 0, 0, which means everything over here is going to work, right? Let's shade all this stuff. Man, I wish I had my lab here so I could just hit the fill button, but you know, there is value in doing these by hand, I think, before you start punching buttons on my lab. Okay, so that's this page. We're going to stop there. We have one more page for this week, and we'll do that in the next video.